Here's a real-world example. In biology, biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. Determine the length of the organism if it is located 25 hundredths millimeters from the bottom of the field of view, round to the nearest hundredth. So we can come up with this diagram where this measurement right here is 0.25 millimeters, and we want to figure out the length of this organism. First of all, we need to understand that the two chords of a circle are shown. You know that the diameter is 2 millimeters and that the organism is 25 hundredths of a millimeter from the bottom. So since the diameter is 2, we can subtract that 25 hundredths from that and get 1.75 for this line segment we'll call EB. So we've drawn a model using a circle. We're going to let x represent the unknown measure of the equal lengths of the chord HF, which is the length of the organism. Now the reason we know this is equal is because EB and HF are perpendicular. And so if you have a diameter or a radius that's perpendicular to a chord, it splits that chord in half. Now we're going to use the products of the lengths of the intersecting chords to find the length of the organism. So the product of the intersecting chord segments is equal. So we'll substitute in, so we have x times x equals 1.75 times 0.25. When we multiply that out, we get x squared equals 4,375 10,000ths, and then we'll square root both sides, and remember we want our final answer to be in hundredths. So when we square root that, we get 66 hundredths, so that means our final answer is 66 hundredths of a millimeter for the length of that organism.